I'm Tim O'Neill, Director of Product Management for AIM Solder, and I want to share some exciting news with you. We are pleased to announce the release of a revolutionary new no-clean solder paste, V9. V9 has been developed to solve one of the most difficult issues facing PCB assemblers, voids. Whether BGA, LGA, or on QFN components, reduced voiding is always preferred. V9 is the result of hundreds of hours of development and testing. AIM's R&D team has developed a product that not only reduces voiding, but also offers class-leading print performance, powerful wetting to all substrate and component surface finishes, and leaves a high reliability, pin-testable residue. Let's take a closer look at how V9 can help you reduce voiding, increase product quality, and customer satisfaction. V9 is currently available in Type 4 SAC 305 and available to sample from your AIM Regional Sales Manager, Representative, or distributor. The part numbers are below. Let's review some of the technical attributes of AIM V9. It's low voiding, as low as 1% on BGA and less than 5% on bottom terminated components. It's capable of consistent printing on area ratios of less than 0.66 and as low as 0.5 when using Type 4 powder. That stable print performance is sustainable for up to 12 hours on a production line. High reliability SIR residue, REACH and RoHS compliant, and as I mentioned earlier, available in SAC 305 T4 in jars and cartridges. Here's an overview of the void studies performed while developing V9. AIM's R&D staff tests solder paste under a variety of conditions to replicate all of the manufacturing environments and applications a product might encounter. We start with a linear ramp to spike profile, or RTS profile. This type of profile promotes wetting and reduces the assembly's thermal exposure and oxide formation during reflow. We also test a ramp soak spike profile. This profile is used to minimize the delta T on assemblies where thermal mismatches are present. These are representative of the wide variety of conditions AIM R&D staff subjected V9 to during product development. This is done to ensure that V9 will perform in a 5-zone tabletop oven and a 15-zone convection oven using nitrogen and everything in between. The results on this BGA 196 using a ramp to spike profile clearly demonstrates the performance gains when using V9. Maximum voids are reduced by half, and in the real world, the largest voids are the voids that attract the most attention. Therefore, reducing large void formation is an important attribute of a low voiding solder paste. And in a ramp soak spike profile, similar gains are realized with nearly a 50% reduction in the average void and the max void. Here are the box plot graphs from the large data set that was used to determine V9's void characteristics. It shows that V9 significantly reduces voiding on all profiles. This includes a profile that we use to test the quote-unquote durability of a paste in the reflow oven. Long, hot profiles can deplete flux activators and increase oxide formation, which impacts solder quality. LGAs represent a special challenge in void reduction as the entire solder inconnect is solder paste and approximately 50% flux by volume. During solidification, the flux becomes part of the solder joint, resulting in the presence of voids. This graph demonstrates V9 resulted in average voids in the single digits. QFN voiding on ground pads is the most visible voiding on a PCB assembly, and as a result, the one most often associated with paste void performance. As you can see in this case, in a ramp to spike profile, on a single row QFN 32, V9 voiding is low, with the voids well dispersed. Similar results are obtained using a ramp soak spike profile. Here again is a box plot with a much larger sample size demonstrating V9 with an average void performance below 15% and a maximum well below 20%. IPC guidelines for permissible void percentage on QFN ground pads is less than 50%, but everybody wants far less. A low voiding paste is great, but if it doesn't print well, it's not going to meet the needs of the customer. Not only does V9 reduce voiding, it also prints fine feature devices as well as its predecessor M8 and many competitor products. Printer setup is listed below, and print performance was tested on 4, 5, and 6 mil stencils. V9 transfer efficiency on both 0201 and 01005 components is exceptional. In this worst case, uncoated, laser cut 5 mil or 120 micron stencil, V9 was able to obtain transfer efficiencies of approximately 80% on both styles of components. Paste not only has to have high transfer efficiency, but it needs to be consistent as well. V9's standard deviation is well below 10%, indicating a process that is in control. After printing, reflow. Solder reflow is the step in the process when the parts come together to create a single integrated device. V9 not only needs to be low voiding, but it must create well-wetted, robust solder joints leaving minimal residue. It must be capable of achieving these results under all reflow conditions and on all surface finishes. A common defect with modern high transfer solder paste are solder beads or mid-chip balls. V9 reduces mid-chip beading even when stencil design has not been optimized. Other than solder, the only thing left on the assembly after reflow is flux residue. V9 residue is barely visible and has proven to reduce false calls on ICT. In addition, V9 residue electrochemical properties are excellent with high SIR values. As you can see in the graph below, V9 SIR values are nearly as high as the control coupon where no flux residue is present. V9 residue is aesthetically pleasing, improving the accurate perception of high quality. We've also seen where V9 can make SAC 305 solder joints with improved luster. Again, AIM V9 low voiding, no clean solder paste. Voids as low as 1% on BGA and BTC, capable of consistent printing in fine features, and that print performance can last for up to 12 hours on the printer in a production environment. The residue that's left behind is high reliability, aesthetically pleasing, REACH and RoHS compliant, and currently available in SAC 305 T4 from your AIM regional sales manager, representative, or distributor. For more information about V9, visit www.aimsolder.com. We look forward to working with you and continue to develop innovative products to meet your needs. Thank you.